Lecture 3B. Here we're going to have a look at some of the methodologies, just to give you an idea. You're not expected to use these methodologies, but at least it gives you an idea of the kind of things that exist. IBM Consulting Group state, let's get clear what we mean by methodology. It is the roles, teams, skills, processes, techniques, tools and standards used by the project team. So in my version of that, in order for it to be called a methodology, you need to have the processes, techniques, standards that are used by the team that have the roles and the skills. For instance, you do not have a plan-driven methodology. You have plan-driven approaches that have lots of different types of methodology. Same goes for the agile approach. So if we say a method, it is just that. It's an approach, a way of doing things. But methodology has to include processes, techniques, standards, and sometimes tools. Every project needs a slightly different methodology based on people characteristics, the project's specific priorities, and the technologies being used. According to Coburn in 2003, he said his results from a research indicated that a team's methodology should be personalised to the team during the project and may even change during the project. So what is the aim of using a systems methodology? It basically is to ensure that the aim of the business is met. So what actually do they want? What is it that they want? So understanding their domain, understanding their business roles, and the aim of the specification is understood. And more importantly, that the project is planned, thought out, and properly controlled to give it every chance of success. Someone once said, a project is like a well-behaved child until your back is turned. And I think you need to remember this, especially in your second semester. You might think that you have control of the project and then something happens. However, a methodology, and this is really an important aspect, does not guarantee success. It's just a tool. It's a method to help an analyst analyse, sort out the complexity of a present system, and bring a solution of the required system. It's a way of communicating with each other. It's a way of using standards. You still have to have the skills. You still have to be able to code. You still have to be able to analyse. It's just a way to include all of these things and to ensure that you follow a path. So we're going to cover stages of systems analysis and design rather than just the full life cycle. We're looking at analysis and design. So in the feasibility definition stage, which is our initial analysis, we're going to look at, is it possible to do? Do we have the technology and resources? And then you put a plan together. What methodology am I going to use? What am I going to do? In the analysis and definition, which is our full analysis, you're going to look at the current system, whether it's manual or computerised. Understand the requirements, understand the business needs. In the design stage, we're going to look at how to design new solutions for software and hardware, how to model the design. Within this, we're going to use processes, tools, techniques, manage projects. You'll validate, evolve by interacting with stakeholders. And in a real project, you have to ensure you're on budget, on time, and that it's of quality. Okay, systems analysis, design and development. We looked previously at the development life cycle. So for instance, somebody initiates it, usually it's managers or people above you, or somebody else initiates it and asks you to do something. You either do a feasibility or you go straight into analysis. It just depends on the complexity of it. If you do a feasibility, you'd go into analysis, or you'd go straight into analysis if it's not that complex. Then you do your design, your implementation and maintenance. In software engineering terms, this is the definition, development and maintenance that we talked about in the last lecture. However, remember, it doesn't really matter what you develop, you're always going to do some form of analysis, design, implementation, maintenance. Always in that order. So it might not be like the waterfall cycle where you go analysis, then you stop, and then you do design, then you stop, then you do implement, then you stop, then you do maintenance. It could be iterative, it could be incremental, it doesn't really matter, but those phases in the development life cycle always exist regardless of what methodology you use. Now within the software development life cycle we have the development process models. These really are how that life cycle is used. For instance, it can be used in a waterfall way, which is one step after the other, and once one step is finished, you complete that and go on to the next phase. It could be spiral, it could be iterative and incremental, like the unified process or RUP, reuse, or some form of agile way of doing it. Let's have a look at methodologies and frameworks. Basically, methodologies include tasks, techniques, tools, and documentation. Now, some methodologies are so strict in what and when and how you use the above, others can be considered as a framework. So, many projects that fail are due to lack of either no methodology or poor project management skills. Now, the tasks might be things like analysis. So in the analysis stage you would use these techniques, and in the tools could be software that you actually need. The techniques would be things like, okay, in the analysis stage you could do use case, you could do that. So some methodologies will be descriptive in what they expect you to do and how they expect you to do and what they expect you to do. Some methodologies have a lot of documentation that go with these tasks and techniques that you have to perform, and some don't. Now remember that these methodologies really are ways of helping you develop a system. They include tools, tasks, techniques, documentation. They're really to help an analyst analyse, sort out the complexity of a present system and bring a solution of the required system. It does not, however, guarantee success. You have to be good at what you do, you have to have good programmers with you, you have to have a good analyst, a good project manager, otherwise it could still fail. The first methodology we're going to look at is SSADM, which stands for Structured Systems Analysis and Design. Now, there are many analysis and design methodologies in use today, but the most well-known structured methodology is probably SSADM. It was originally used by the UK government, and this is mainly split into a feasibility study, a business systems option, and a technical system option. The new version, however, enables an analyst to use parts that are relevant to a particular project. The old one was considered to impose a straitjacket on new development methods, and usually SSADM follows the waterfall model. The basic premise of SSADM is that usually an organisation will have an IT strategic plan, which would run along hand in hand with the business strategic plan. The IT strategic plan is basically what, when, how and who. When to change or expand the system, how best to consider doing it, who it would involve, and what to do to actually meet the business need. This is all in relation to the use of any information technology to ensure the efficiency and continued growth of a business. Obviously this is a simplified version that I'm giving you here. So, under management control you've got the strategic planning, which incorporates the strategic study, which is selecting the project, and then the business study, which involves the project initiation document. And once the IT strategic team and business managers decide to follow a course of action to meet their business need, the analysis begins. In the analysis, first a feasibility study is carried out. Now, depending on the structure of the organisation, a feasibility study is either carried out by the organisation itself or by an outside analyst. The feasibility stage is really to see if the proposed plan of action is feasible in terms of resources, viability of the proposal, and whether such a course of action is practical. Now, the report that comes out of a feasibility study could include things like context diagrams or first-level DFDs, and this report really would allow the managers and the IT people to take an informed decision to follow a particular plan or choose an option. And once they've made their decision, then a terms of reference is drawn up. A terms of reference is a more in-depth request stating what the company requires, and it will also include a problem statement which identifies particular problems encountered. Then an in-depth analysis can be carried out. The requirements analysis will be the first full analysis stage, really, in the full study. A requirement specification is then drawn up and a logical system specification is done. So these are all to do with the full study of the analysis stage. In the development phase, you get the physical design. Then the next stage will be the construct and test and the production. Now, construct and test is really the code, the testing, the implementation and maintenance, but it's not covered by SSADM. The SSADM covers feasibility and the full study and the physical design, and nothing more. The rest of it doesn't include the documentation for that. As I stated, SSADM does not cover the coding and the implementation of the actual system. This is where the programmer takes over, or the analyst programmer takes on another role. The aim of SSADM really is to tell you what tasks they are, so what is to be done. And in our instance, it would be things like the feasibility study, the requirements and requirement specification, physical design, and then it's got to be constructed, so the coding, the testing, the implementation. And the techniques is how the work is to be done. Now, in the construct and test, it doesn't tell you how that's to be done, but the rest of it does. So it'll tell you how you carry out the feasibility study and what techniques you're going to use for those. So for instance, in the requirements analysis, as we said, we would probably need a DFD, context diagram, and in the physical design you might need an ERD, entity relationship diagram. And the documents are where the information goes, so there would be specific documents that you would have to fill in for all these things. So as you can see, that SSADM is quite documentation and intensive, and it follows specific things that you have to do in a particular order. Hence, it's a plan-driven methodology. It uses the plan-driven approach, and SSADM is a methodology, often following the waterfall model life cycle. The Rationale Unified Process, RUP for short, and that is a modern generic process derived from the work on the UML and associated process. It brings together aspects of the three generic process models discussed previously, normally described from three perspectives. It looks at from a dynamic perspective that shows phases over time, a static perspective that shows the process activities that are required, and a proactive perspective that suggests the good practice. So let's have a look at these. We're going to look at the dynamic phases in RUP. And really, RUP model provides guidelines, templates for software engineering team to take full advantage. It's incremental. So the product is designed, implemented, integrated and tested as a series of incremental builds. So at first we have inception, and that really establishes the business case for the system. We then have elaboration, where you develop an understanding of the problem domain and the system architecture. The construction, you can see that that phase is quite a large chunk of it. So that's the system design, the programming and the testing. And finally, we have transition, which deploys the system to its operating environment. We're now going to consider the static workflows in RUP. This is taken from Ian Somerville's chapter. So the workflows are business modelling. Now, really here the business processes are modelled using business use cases. And the next one, requirements. And actors who interact with the system are identified here and use cases are developed to model the system requirements. Analysis and design. A design model is created and documented using architectural models, component models, object models and sequence models. The implementation. The components in the system are implemented and structured into implementation subsystems. Automatic code generation from design models helps accelerate this process. For instance, in this framework of RUP methodology, they actually use different types of tools, and one of them is automatic code generation. Testing. Now, testing is an iterative process that's carried out in conjunction with implementation. However, system testing, there's also a specific workflow called testing, which is at the completion of the implementation there will be a system testing. The deployment is when the product is released and it's distributed to users and installed in their environment. Configuration and change management. This would support workflow managed changes to the system, so anything that needs changing. Project management. This actually supports workflow and manages the system's development, so this is really whatever project management tool that they're going to use. The environment. This workflow is concerned with making appropriate software tools available to the software development team. So if they're going to need something that will help with the code, or need something that will help with the UML, all this is sorted out for them. Okay, we stated that RUP is looked at from 3 perspectives, and this is the third perspective, which is RUP good practice. And that is developing software iteratively. So you have to plan the increments based on customer priorities and deliver the highest priority increment first. And manage requirements, explicitly document customer requirements and keep track of changes to these requirements. Here you can see that documentation is quite important. It's one of the reasons that RUP, though initially considered as an agile methodology, because RUP state, well, actually it's just a framework, you don't have to use everything. It does, however, have so many requirements for documentation and so many workflow practices. Okay, the next one is use component-based architecture. That's organising the system architecture as a set of reusable components. RUP good practice continued. Okay, visually model software, so use things like graphical UML models to present static or dynamic views of the software. And then verify software quality, ensure that the software meets organisational quality standards. Control changes to software, manage software changes using a change management system and configuration management tools. So those 6 best practices really are described in the RUP. I suppose it lists 6 ideas to follow when designing any software project to minimise faults and increase productivity. Okay, main key points. The Rational Unified Process, RUP, is a modern generic process model that's organised into phases. So you have inception, elaboration, construction and transition that we looked at earlier. But it separates activities. For instance, within it you've got requirements, analysis, design. from these phases. So in inception, you might have different activities going through it. In elaboration you would, and so would you in construction and transition. Now, Agile Unified Process, AUP, is a simplified version of the RUP, and that's been developed by Scott Ambler. AUP is considered as Agile, RUP is considered as plan-driven. A brief note about AUP, but though we're not going to cover it, but it really applies Agile techniques, including test-driven development, Agile modelling using UML, Agile change management, and database refactoring to improve productivity. Here's a quick look at a diagram really of RUP, and really just to show you that it's an iterative software development process framework. It's more a framework really than a methodology, but though they say it's not a single concrete prescriptive process, but rather adaptable process or framework, and it's intended to be tailored by the development organisation and software project teams. It's a specific implementation of the unified process that was originally done by IBM. Bigger diagram really showing everything that it requires, so you can see why, again, as I stated, why it would be considered something really more plan-driven than an agile framework, because it's got so many steps and so many things that you have to consider. Okay, let's look at another methodology now. This time we looked at RUP and SSADM. Both of those were plan-driven. We briefly mentioned AUP at the end of the RUP session, which was an agile method, or an agile approach really. Now we're going to look at Dynamic Systems Development Method, DSDM for short. This one is an agile methodology. DSDM consortium is really UK based. It's been going since 1994, and an important point here, it's vendor independent. The latest version is known as DSDM Return, and it has Agile Project Management and Delivery Framework, so it's really known as an Agile Project Management and Delivery Framework. Even though it's considered a methodology, it's also considered a framework. But it does cover the entire life cycle of a project. Now, the philosophy of the DSDM is that any project must be aligned to clearly defined strategic goals and focus upon early delivery of real benefits to the business. It's also designed to be easily tailored and used in conjunction, for instance, with traditional methods such as Prince2, which is a project management thing, or to complement other agile approaches such as Scrum. Again, Scrum is also project management. So it includes project management tools, or it doesn't include the tools, but it enables you to use other tools if you want to. Let's have a quick look really at the turn framework. For instance, you've got the philosophy, and the philosophy is, we mentioned it earlier, that project must be aligned to clearly defined strategic goals and early delivery of real benefits to the business. And it also has 8 working principles which guide the practitioners in the adoption of the philosophy. Now, these are supported by a project life cycle, which are known as the process. So the process is the project life cycle, and they have defined products, people, which really are the roles and responsibilities, and then the recommended practices, which really are the recommended techniques that you could use. The Return principles. These support the Return's philosophy really, and they do state in their DSDM consortium page that if you don't follow some of them then you won't get the full benefit. So you're supposed to follow all the principles really. And that is focus on the business need, deliver on time, collaborate, never compromise quality, build incrementally from firm foundations, develop iteratively, communicate continuously and clearly, and demonstrate control. We can see here the DSDM turn life cycle phases, I suppose. You can see you've got feasibility, the foundations, the exploration, engineering, deployment, post-project. So basically everything you do, you look at it, is it feasible? Then you decide, then you explore, so that's the analysis, then you build it, then you deploy it. So you're still following all the things of the life cycle, it's just in a different way. And depending on the size or complexity or risk of the project, some phases can sometimes be merged. Let's have a quick look at the key ATTURN techniques that are used really. And these support the adoption of the ATTURN principles that we mentioned earlier, those 8 principles. So really, you've got iterative development, which we've talked about, time boxing, Moscow prioritisation, which we will actually be covering ourselves, facilitated workshops, and modelling. So modelling are different techniques they use. And one of the things they do say about modelling in DSDM is it doesn't really matter what you use. So unlike our UP that states you have to use OO, they expect you to use cases, sequence diagrams. One of the things about the DSDM is that you can use any structured techniques or OO techniques. It doesn't really matter as long as you can communicate those. So if, for instance, if your team is used to using DFDs, then fine, use those. It doesn't really matter. Okay, so I've called this software engineering diversity really, following on from Somerville, but really it's just to show you that there are many different types of software systems and there's no universal set of software techniques that's applicable to all of these. The software engineering methods and tools used depend on the type of application being developed, the requirements of the customer and the background of the development team. And this really, we hope, is an ethos that we can show you all the way through the module. That's why we're not actually going to teach you specific methodology. We're going to use a mixture of different things. We're looking at really, is a plan-driven best way, agile best way, but we're going to show you the techniques that are used in the majority of these. Thank you.